Hi all, again this is Dr.Senthilkumar continuing the series lecture of Heat and Mass Transfer Unit 1. Now let me see a numerical problem. The problem given is calculate the critical radius of insulation for a asbestos having the thermal conductivity 0.172 watts per meter Kelvin surrounding by a pipe and exposed to room air at 300 Kelvin with heat transfer coefficient H, which is equal to 2.8 watts per meter square Kelvin. Calculate the heat loss from 475 Kelvin 60 mm diameter pipe when covered with the critical radius and insulation and without the value. So the given data, we know that thermal conductivity is given, which is 0.1 watts per meter Kelvin. The ambient temperature is given, which is 300 Kelvin, and moreover the heat transfer coefficient is given 2.8 watts per meter squared Kelvin, and T is given, which is as 475 Kelvin. So diameter also given, which is 60 millimeter. So critical thickness, for to find out that, we have know already formula that RC, that is critical radius, which is K by H. K value is given, H value is given, so which is in meter. I am converting it to meter, 0.0614543 meter, and RC becomes 61.43 in millimeter, conversion of millimeter, meter to millimeter. So without insulation, they are asking the radius of insulation without insulation. So 2 pi T1 minus T infinity divided by ln of RC by R1 divided by K plus 1 by HRC, which is the formula which already derived here in the class and the previous lecture also. And 2 pi into T1 value is known and the ambient value also known, and RC value we have found it here, and R1 value we know already. So this value I am substituting. H value is given the problem, RC no, thermal conductivity also no. If I substitute without insulation, the Q becomes the value with insulation the Q value becomes as 110.16 watts per meter. Same way, without insulation, that means considering the convection, HA delta T, which is nothing but Newton's law of cooling. H value we know, 2 pi R value we know, T1 value, T infinity value we know. Since we substitute without insulation 92.36 watts per meter Kelvin heat transfer, and with the insulation 110.16 watts per meter heat transfer is taking place. This is the tutorial number 2 problem. Let me see another problem. A 10 mm cable is to be laid in atmosphere 20 degrees centigrade with outside heat transfer coefficient of 8.5 watts per meter squared Kelvin. The surface temperature of cable is likely to be 65 degrees centigrade due to heat generation. Within that will be rubber insulation of K, which is equal to 1 watt per meter Kelvin thermal conductivity. Will be effective? If yes, how much? If the question is whether it is effective, if so, what is the value? Let me see. R1 equal to 10 by 2, that is 5 mm, and T infinity will given, T1 is given, H value also given. For a cable, considering it is like cylindrical shape, RC equal to K by H like previous problem. We are finding the value in both millimeter and meter for a given value. A rubber insulation of thickness T equal to RC minus R1, 18.231 minus 5. So it will be effective in heat dissipation. So 13.235 mm will be effective in heat dissipation. Maximum heat dissipation per length is found out here. Q max by L, which is equal to 2 pi. Already we know this formula in the previous problem we have solved. Once we solve it by substituting the value, 19.1 watts per meter per length. Heat transfer per length will be 19.1 watts per meter. So these two problems explains how the heat dissipation taking place with consideration of cylindrical in this problem, how the dissipation is taking place, what is the formula, how to use the formula, how to solve it, how to place it. So, in previous problem also like how the conduction is considered for the circular radius insulation and how to solve that. So, I conclude this session. If any discussion we can see in the class or flip the class. Thank you.